Hi there. Okay, we're going to be talking about the nature of electricity. To get ready for our class, we're going to do a bunch of fun experiments. So, what is static electricity? Feel free to pause the video as we're going through. If you need to, I will talk as if I am writing at the same time as you. Okay? So, what is static electricity? Static electricity is a situation where electrical charges build up on the surface of material. It is called static because there is no current flowing in AC or DC electricity. Okay? It is usually caused when materials are rubbed together. Okay? The result is that objects may be attracted to each other or may even cause a spark to jump from one object to another. So if you try it and you take your hands and put them together and rub them together, what do you feel? Okay, the heat that's created, okay, that's friction, and eventually you could build up some static depending on what two materials were rubbing together. Okay. Introduction to electrostatics. Many different materials can be electrified by friction. The charge is the name we apply to the property we have observed. An object can be charged by friction and the charge gives rise to forces of attraction and repulsion. I'm sure you played with magnets, and if you push the two ends together that are the same pole, they repulse, they push away from each other, whereas if you put opposite poles near each other, they are attracted. Okay, exactly the same thing. Given the observations of attraction and repulsion, we can say that two charges exist, or two charged states exist. Charges, which are like, that is, created in similar circumstances, repel, and charges which are unlike, that is, created in different circumstances or not the same, attract. A neutral object is attracted to both positive and negative charges. Okay. The existence of two charged states can be explained by three models, and I'm going to tell you them very briefly here. Okay? So one is called the fluid model. Okay, so in here, a neutral object has a natural amount of electric fluid. A charged object either has too much or too little fluid. And this was Ben Franklin's model. He came up with this idea. As a result, Ben Franklin coined the terms positive and negative. So if you look over here, can I write on this? Yes. And laser pointer. Okay, so here is a neutral object, okay, and notice how we'll say the purple is the liquid and it fills the pill or the space entirely, okay? But if you look here at the negative pill or the negative space, notice how there's like a line inside there And that's showing that the liquid is only going, it's not going all the way to the end, okay? Whereas the positive space, look at it's overfilling the space. So it has way too much to fit inside that space. So this would be positively charged, this is negatively charged, and this is neutral. Okay, this is kind of the progression of how things came about. Okay. Where'd my pointer go? Okay, next step. That did not go well. Okay, here we go. Figured it out. Okay, the next one is the two fluid model. Okay, here a neutral object has equal amounts of each fluid. Okay, and a charged object has more of one or the other. So for example, over here, okay, this would be a picture of a neutral object. So notice how it has two liquids. One was vitreous and one's resinous. And I'm pretty sure vitreous was considered the positively charged liquid and resinous was the negatively charged liquid. But if you look at the next one here, notice how there's so much more resinous liquid. That would mean that this was a negatively charged object. Okay. And vice versa. Here there's way more vitreous liquid. Okay, so this would be positive and this would be negative. Okay, so that was a two fluid model. Okay, oops. Then along came the particle model. Sorry that those did not come up in order, but that's okay. Okay, there are two kinds of particles. There are positive and negative particles. Okay, and a charged object has more of one particle or the other. Okay, so notice how we're kind of evolving, okay, from the one fluid to the two fluid, and now this particle model. We have come to accept the particle model of electricity because of later discoveries, including Weatherford's gold foil experiment and Millikan's oil drop experiment. So pretty much because of more discoveries that were made, hypotheses and theories were refined, and now we've realized the particle model is the most correct model. Okay, so let's look at that particle model a little bit more. And this is going to be an introduction that's going to come back to us again when we do chemistry. Okay, so the particle model. There are two types of charged particles. There are positive, called protons, and negative ones, called electrons. Charge cannot be created or destroyed. Charge is conserved. Okay, so it moves from one object to the next. It doesn't just spontaneously disappear. It isn't all of a sudden spontaneously created. Okay, positive charges are fixed in the nucleus. Okay, and negative charges are free to move as they orbit around the nucleus. Okay, so if I were to draw a little picture here, here is my nucleus, and here is where I have all of my protons, all my positively charged protons, and then orbiting around, okay, orbiting around the nucleus is my negatively charged particles, okay? A neutral object has an equal number of positive and negative charges, which makes sense, right? If you have 3 positive charges and 3 negative charges, 3 minus 3 is 0, okay? A negative object has an excess of negative charge because the electrons were added to it. And I'm going to do an example with you where we're going to draw it out. Okay. A positive object has a deficit, which just means it's short, okay, has a deficit of negative charges because electrons were removed from it. Charge is shared by contact. Okay, think about when you are on a carpet with your socks and you slide your feet along and you are building up a charge through friction. Okay, and then when you go and touch the doorknob, okay, the charge is shared. You are moving those electrons from your fingertips to the doorknob. Okay, so materials which allow charge to move easily are called conductors. Okay, and materials which do not allow charge to move easily are called insulators. Like charges repel, and unlike charges attract. Okay, so that's the particle model, and it's pretty common sense too, and I'm sure you've come across these things in your daily life as well, okay, but maybe you haven't thought about it like this. So the law of conservation of electric charge says that you can never create a net electric charge. Instead, charge can only move from one place to another. So using our sock on the carpet example, you don't all of a sudden generate negative electrons on your own without friction, okay? Electrons are constantly moving, okay? Yes. Okay, so the next thing I want to tell you about is charging by contact. So like we were talking about touching the doorknob. So electrons are so easily transferred to or from some atoms that friction provides enough energy to cause the transfer to take place. Okay, so let's think about this, and we're going to try this out ourselves in class too. If you rub a plastic straw, so plastic straw with wool, okay, you'll create an electrostatic charge in the straw. Okay, that means we've charged the straw. The wool transfers electrons to the plastic straw. Transfers electrons to the plastic straw, and it becomes negatively charged. The wool, because it has lost electrons, becomes positively charged. Okay? If you're like, Ms. Labik, I still don't get it, don't worry, we'll do another example. So because we have come to accept the particle model of matter, we fix the positive charge and allow the negative charge to move. Therefore, an object becomes positively charged if it loses negative charges and becomes negatively charged if it gains negative charges. Okay, let's try another example. Okay, and this one I'd like you to draw. So either you can draw it in that space, or you can draw it on the back side. Okay. You don't have to draw a horse and a comb. You can draw like a square and a circle if you want, or a rectangle and a triangle for the horse. But you'll see what the idea is right away. Okay, so I want you to draw two objects. Okay, and on the comb object, I want you to add 2 protons, so 2 positives, and 2 electrons, so 2 negatives. Okay, that makes the comb neutral. It has 2 of each. Okay, and on the horse here, handsome as he is, I want you to add 4 protons and 4 electrons. Okay, so he is also neutral. Okay, and you can pause this at any time. So here are 2 neutral objects because they have the same number of positive and negative charges. If we rub them together, what will happen? Do you have a guess? Okay, so if we rub them together, our electrons are going to move from one object to the other. And in this case, we're going to have them move from the horse to the comb. So what is that going to look like now? The electrons move from the horse to the comb. Now the horse has a positive charge because it has more positive than negative, and the comb has a negative charge. It has more negative than positives. Notice that the positive charges don't move. Okay, so now see we had 2 positive charges originally. Now here's our originally 2 positive charges, still have 2 positive charges. Okay. Notice how we had 2 negatives. Now we have 5 negatives. So this has a negative charge. Notice how we had 1, 2, 3, 4 positives before. Oh, not sure where this one went. We should still have 4 positives on our horse. Okay, but we've lost a bunch of negatives. Okay, so this horse is positively charged. It has more positive than negatives. Okay. And that's it for understanding static. Okay, tomorrow we're going to, or the next time we come into class, we're going to do a bunch of different labs to look through this. So I hope you feel comfortable and see you soon.